Number 12 is one where you want to convert a rectangular equation into polar. And it's only going to be this kind of problem, going from rectangular to polar. It's also going to ask you to solve for r. So we want to know the conversion formulas for that. So let me go ahead and put those off to the side here. So you want to know these conversion formulas, and these are the ones that are going to apply for this particular problem. You're going to use x equals r cosine and y equals r sine. Now you don't have to use it on this problem, but here's a third formula that you want to be aware of as well as you do these. So these are the three formulas that are going to apply to this particular problem that you want to use. Okay, so everywhere you see an x, you're going to replace it with r cosine. Where I see a y, I'm going to replace it with r sine theta. So we're going to substitute those in there and simplify it. And then we're going to solve for r. Okay, so x, we have r cosine, we have a square. So it means that we have to square that one. So it's going to look like this. We have r cosine theta squared. You're multiplying it by r sine theta. That equals 4. So we just put in the substitutions for each of those, for x and for y, just by using these here. So we didn't use the third one, but it's also one you want to be aware of because there could be an x squared plus y squared appearing somewhere. So you want to be aware of that formula as well. Okay, so now we have this complete. We want to simplify this, so we're going to combine this together. First thing we have to do is square all that. Okay, so we get r squared cosine squared. Because this is all multiplication, we can multiply this in any order. So I'm going to multiply the r's together, and I'm going to get r cubed. And then the other ones, it doesn't matter what order you write those in. Okay, so I didn't do any factoring here. All I did was just move the r over here and multiply it and make it a cube. Next thing you want to do is solve for r cubed. So I'm going to divide both sides by cosine squared sine. And then I'll get r cubed equals 4 over cosine squared theta sine theta. And we're almost done. We need to take the cube root of both sides because we want to get r by itself. Now if you take an even root of both sides, that's where you always need the plus or minus. So we've already seen that happen so far on this sample exam. We had some pluses and minuses that came up. But we're doing a cube root. Cube root, you do not have to use plus or minus. You just get the positive answer. So we're going to do cube root 4 over cosine squared theta sine theta. And it is possible that you could put in an identity for this. If you wanted to put identities in for that one, you can, but it's not necessary. I'll take the answer just like that. But just know that you could do a little bit more with this. Since we have 1 over cosine, you could change it into a secant squared. 1 over sine is cosecant. So on the answer key, I did show that. But on the test itself, it's okay to leave your answer in terms of sines and cosines.